हेलो दोस्तों, कैसे हो। मेरे इस YouTube चैनल में आपका स्वागत है। तो चलिए शुरू करते हैं।
Today I will explain modes of failure. What are the various modes of failure? That is another topic in your syllabus, and each one of you should know what are the various modes of failure. If you ask some people, they may say that tensile, shear, crushing, these are the modes of failure. No, these are not the modes of failure. Okay, the modes of failure are मोड्स ऑफ फेलियर का मतलब होता है वो फेल कैसे हो रहा है, किस किस स्ट्रेस में फेल हो रहा है, किस शियर में हो रहा है, टेंसाइल में हो रहा है, क्रशिंग में हो रहा है, ये नहीं होता है मोड्स ऑफ फेलियर. वन, इट कैन बी बाय इलास्टिक डिफ्लेक्शन. सेकंड, इट कैन बी बाय yielding, also called as जनरल yielding. जनरल yielding, ये बहुत इंपॉर्टेंट टॉपिक है. दिस इज वेरी मच इंपॉर्टेंट फॉर ईच वन ऑफ यू. एंड थर्ड इज फ्रैक्चर. Third is by fracture. Now, first I will explain what is yielding. All of you know what is yielding and how and where it happens. Let's see what happens. This is the stress strain curve that we draw, correct? Now, in this stress strain curve, there are various points: proportional limit, elastic limit, and upper yield point, lower yield point. So, I will talk about yield point. Yield point. Yield point. ये ऊपर चला गया अभी. See, yield point. Okay. Since general yielding मतलब yield point. So when yielding of material starts, it is considered as failure. When yielding of material start, it is considered as failure. And then you may ask me, sir, when yielding of material start, it is considered as failure, then why this fracture is written here? Because this is applicable to what? This is applicable to ductile material. Ductile material. This is applicable to ductile material. This is number 2. And number 3 is applicable to, that is fracture. It is applicable to brittle material. Brittle material. So I will talk about one afterwards. First, get this second and third clear. When I say fracture, which material will fracture? Both ductile and brittle, both material will get fracture. But in brittle material will fracture without any intimation. Okay, without any intimation, it will fracture all of a sudden, and the fracture develops because of the formation of crack. It can be internal crack as well. So we don't know when the brittle material is going to fail. Okay, so brittle material fails means it has fractured. It has fractured. That is, it has broken into two parts. It has broken into two parts. So it is failure. Now, when we talk about ductile material, what is happening in ductile material here? There is yielding of material. What do you mean by yielding? Yielding means elongation. Okay, you must have performed this. This you must have performed on a UTM machine. Okay, what is happening here? From here to here, the length of the specimen is increasing and the diameter is decreasing. The length of the specimen is increasing. Now, when I say length of the specimen is increasing, it means that will it come back to its original length? No, it is not going to come back to its original length. Now, tell me that here this is a shaft. On this shaft, I have mounted a gear. I have mounted a gear. Okay. Now this gear is in mesh with another gear. This is in mesh with another gear. We call it as pinion. And this is what? This is the shaft. And consider that the length of this shaft from here to here, there is a bearing here and there is another bearing here. There is another bearing here. And the length of the shaft between the bearing is 20 meter. Or let us take it as say 20 mm. 20 mm. Okay, it's too small. Take it as 200 mm. Now, because of yielding, why yielding will happen? Yielding will happen because of the weight of the shaft, weight of the gear and the shaft. This will yield, and then when it yields, what will happen? If I exaggerate this, then this is the shaft, this is the gear which is mounted on it, and then there is a pinion which is mounted here below this. Now, if the length increases, then it will be like sagging. And when it will be like sagging, that time what will happen? This gear and this gear will not mesh properly. Okay. So what is happening here? Here there is yielding of material. Uska length बढ़ गया. Then that will not be of any use. So this is the mode of failure, yielding. And this happens only in ductile material, and not in brittle material. So these are the three modes of failure: yielding, elastic deflection, and fracture. Now I have explained you what is yielding and what is fracture. Now come to this elastic deflection. So how do we design a shaft? We design a shaft based on what? Based on strength and stiffness. And what is the equation that we use for this? We use the torsion equation. T by J is equal to C theta by L equal to tau by R. So when I am designing a shaft on the basis of strength, the equation will be T by J is equal to tau by R. And when I am designing the shaft on the basis of rigidity and stiffness, then the equation will be T by J is equal to C theta by L. So in this, if you have studied, there can be elastic deflection. In the shaft. And the shaft will no longer be of the same length. The shaft will no longer be of the same length, and what will happen? It can create either buckling or it can create vibration. It can create either buckling or vibration. Okay, because it is not stiff enough. So that is also considered as failure. For example, consider a column. Okay, this is a column, and when we apply force on this, it may buckle. So buckling is also a type of failure. So you can see there can be buckling of this column, and this buckling of the column can happen because of the elastic deflection. Okay, there is deflection, and that is elastic. Elastic deflection means it is coming back to its original position after the load is removed. So there is deflection, and that is buckling. That is buckling. So in such cases, we will consider that the material is failed. So these are the three modes of failure. In any material: elastic deflection, yielding, and fracture. So when this comes to you as a question in examination, you will have to explain these three cases: failure by elastic deflection, failure by yielding, and failure by fracture. Elastic deflection, it occurs generally in shaft or columns, which can result in buckling or vibration. Then yielding happens in what? Yielding, it happens in any material. It can happen in any material, and but that material has to be a ductile material. And the third case is, it is fracture, and the fracture will happen only in brittle material. Happen only in brittle material, because a ductile material will not be designed till fracture happens. Okay, it will not be designed till that point, till fracture happens. Okay, also remember one thing: when we are designing on the basis of yield strength or ultimate strength. So this will be used only for brittle material, and this will be used only for ductile material. And this permissible stress will always be this value divided by factor of safety, and it will always be this value divided by factor of safety. So ultimate strength I will denote by SUT, and yield strength I will denote by SYT. SYT is yield strength. You can write down this notation somewhere. SYT is yield strength and SUT is ultimate strength, divided by factor of safety.